So imagine this, you built a small side project in your apartment, it's scrappy, it's messy, but it works. And then the impossible happens, it goes viral. Your traffic does not just grow, it doubles every 6 weeks. This is not really a dream scenario and it's a nightmare. Your servers are catching fire, your database is screaming, and you have just three engineers trying to hold it all together. This is the real story of how Pinterest survived its own success to serve 500 million users. So, a quick question. How do you evolve a simple app into a global scale system without it collapsing into a pile of rubble? Right? By the end of this video, you will know the three key decisions that they made that you can apply to your own project, and let's get into it. So, every great system starts small, and what you see here is the initial architecture of Pinterest, right? You can see a bunch of services that they ended up using, right? Now, in 2010, Pinterest wasn't really thinking about scalability, they were thinking about survival, and their goal was speed, right? And their tech stack was what any of us would build for literally a hackathon. See this. They used Nginx as the front door, Python for the app logic because it was fast to write, and a single MySQL DB with a read replica to take some of the load. And obviously they had MongoDB just to handle simple counters like likes and pins. Now, this is the classic junior engineer mindset. And I don't mean that as an insult. It's the right move at the start. But you prioritize features over architectures because you don't even know if you will have users tomorrow, right? You don't know if your app will kind of go viral or it will kind of, go and have a lot of users coming to it. But this approach has a ticking time bomb built into it. And that time bomb exploded. As traffic skyrocketed, every time a new problem appeared, they threw a new tool at it, right? So what they did was, okay, MySQL is slow. What do? They had Redis for caching. You need distributed data. Let's try Cassandra. This other thing called Embase is hyped. Throw in that too. This is a fatal trap. They weren't really building an architecture, they were creating a Franken and shaken stack. Each new DB fixed one problem but created five more. It was chaos. They realized that they did not need more tools, they needed fewer and better ones. And this is where the first critical turning point, and the folks at the Hello World newsletter has done an amazing job at breaking down this exact moment. I will probably give the link in the description to their newsletter, right? So as their article also highlights, piling on tech wasn't the answer and they had to simplify. This is exactly where the senior engineer mindset takes over, right? Instead of adding more, they subtracted. They got rid of MongoDB, Cassandra, Embase for core flows and built their new stable stack on a holy trinity of proven technologies, right? So number one, they used MySQL as source of truth. And for their most critical data like pins, user boards, they needed reliability, right? But how do you scale a relational DB? You don't just make it bigger, you shard it, right? So they slice their DB into hundreds of smaller and independent pieces. So instead of one massive slow DB, they had hundreds of fast ones, and now the problem is solved. Number two, what they did was they started using Redis for what MySQL could not do, right? Now your feed needs to feel instant, right? It should be fast. And a follower graph is complex, and MySQL is too slow for this. So Redis, which lives in memory, handles their feed and social graph, making the user experience feel light and fast, right? Now number three, what they did was they used Memcached as the shock absorber. And this is their purest caching layer, right? It's simple, it's dumb, and it's incredibly fast, right? MySQL, Redis, Memcache, right? You see how they are using tools for specialized use cases. Now, So what Memcached does is it sits in front of everything and absorbs millions of repetitive requests, protecting the DB from unnecessary load. And usually Memcache they use as the system's first line of defense. Now, what they did was they had to tame the monolith. Everything was a monolith until this point, right? So they had to tame it. So their data layer was stable, but their code was still one giant Python monolith. To scale their teams, they had to break it apart into microservices, and this creates new problems, right? So, quick question. Your app needs to send notifications, but it's slow, right? It's a slow process. Sending notifications is a slow process. How do you do it without making the users wait? You create an asynchronous task queue, and that's exactly what they did. Pinterest built PinLater, right? And it's an incredibly fast and reliable queue-based system backed by MySQL. And when a slow job needs to run, it gets put into the queue and a separate worker process handles it later. The user gets an instant response, right? Another problem. With hundreds of services, how do you find each other, right? Hard coding address is a recipe for disaster, and they use Zookeeper as a service registry, like a phone book for their services, right? This made their system resilient and elastic. Now, we need to see in the dark with the data pipelines, right? At this scale, if you cannot just see what's happening, and this is the phase 5 that we're talking about, you are flying blind. Logging isn't a feature, it's the most critical piece of infra you have. So their old system of logging to MySQL was killing it. So they built a modern data pipeline. At its heart, it has Apache Kafka, and think of Kafka as a massive universal firehose. Every single event on the platform flows through it. From there, an internal tool called Secure processes their logs and dumps them into Amazon S3 for long-term storage. You can see in this diagram how each system links to each other, right? So every single event you see goes through Kafka, and then they had an internal tool called Secure that processes these logs and dumps them into Amazon S3 for long-term storage. This is brilliant. It decouples the app from the logging process and gives them a single source of truth for everything. They can now have analytics, detect fraud, monitor system health in real time without even slowing down the main app. Now, honestly, the way they architecture their data pipeline is a pure masterclass, right? And the Hello World article goes into even more details on how Kafka, Secure, and S3 work together. It's required reading if you are into data engineering. I will give the link in the description. Right? So let's route to the 3 key lessons from Pinterest scale. So how did Pinterest scale from a side project to a global giant? It's come down to 3 lessons, right? So before you scale, simplify, right? So they hit a wall when they threw more tech at their problem, right? Their breakthroughs came when they choose fewer and more reliable tools and mastered them. So get rid of complexity as Pinterest did when they had to scale. Now decouple everything, whether it was separating background jobs with PinLater or creating a data Firehose like Kafka, right? They relentlessly decoupled their systems. This allows services to fail independently without bringing the whole site down. Now, use boring and proven tech. They did not scale by chasing hype, they scaled on the back of SQL, Redis, and Memcached. Boring, well documented, right? And these are known to work. And sometimes the most innovative choice is the most reliable one. And this is how Pinterest built an architecture that could withstand a tsunami of users. They started small, survived the chaos, simplified, and scaled by decoupling. So if you want more deep dives like this, breaking down the system design of the world's largest tech companies, hit that subscribe button and let me know in the comments what company I should break down next. And again, a huge thank you to the Hello World newsletter for, this great article on how Pinterest scaled. I will have the link in the description. Thanks for watching and I will see you in the next one.